Hi, this is Joseph Stackhouse from StackTech, and today we'll be doing an informational tutorial on the TinyCircuits Ambient Light TinyShield. This TinyShield features the AMS, formerly known as TAOS, TSL2572 Ambient Light Sensor Diode that responds to light intensity under a variety of lighting conditions. This 2x2mm diode package is mounted onto the TinyShield for easy access to all pins, and to connect to your TinyDuino, of course. The accurate ambient light sensor, known as ALS, measurements are the result of AMS's patented dual diode technology and the UV rejection filter incorporated into the package. In addition, the operating range is extended to 60,000 lux in sunlight when the low gain mode is used. This also allows for operation in infrared light environments. Here you can see the 3.3 volt power supply built into the shield. The shield also incorporates level shifters, so this package can operate between 3 and 5 volts safely. Since the data pins are also accessible via 0.1 inch spaced holes, this means you can also use this module to connect to a different microcontroller or a different system if you wish to do so. The shield uses I2C mode for communication. Arduino pins A4 and A5 are used by this shield. Due to its low power usage, the TinyDuino coin cell battery option can be used to power this shield. The diode has a low power profile. When active, it uses 200 microamperes of power. When in wait mode, it uses 90 microamperes. And in sleep mode, it only uses 2.2 microamperes. The entire shield package is smaller than a quarter, as I will show you later. It measures 20 millimeters by 20 millimeters, and its maximum height is 5.11 millimeters. Some of its other great features are a 45 million-to-1 dynamic range and a wide magnetic field range, plus or minus 8 Oersted. Looking at the current TinyShield compatibility matrix, we can see that this TinyShield does not interfere with any other shields currently. Links to the TinyShield product page, the TinyShield compatibility matrix, and the datasheet of the AMS TSL2572 will be included in the description if you wish to check out the finer details. Given the very high resolution that this module supports, I could think of multiple uses for this shield. You could use it to help control display's backlight, giving you the correct dimming depending on the available ambient light. You could make a keyboard's keys illuminate gradually as the ambient light lowers. It could be used for solar harvesting control to turn solar panels into the optimal path to collect sun rays. It could also be used in a security system. You could turn lights on and off based on the available daylight. Alright, let us get on to the coding. Ken Burns over at TinyCircuits has created a demo sketch which simply spits out the lux value read by the two sensors on the diode. It applies some calculations to get the final lux value. You can find the demo sketch over in the Learn section on the TinyCircuits website. We're going to go through this code step by step really quick. It uses the wire library, initializes the I2C addressing. The wire library begins. We begin serial communications on baud rate 9600. And then the sensor itself initializes. So let's scroll down to the initialize. We see that it starts by writing some registers to the actual sensor. I've pulled up the datasheet here on the right hand side, and I believe on page 13 we will find what these registers are. Here's an entire chart of the registers, and Ken's already commented these. The first one turns the device actually on and gets its state ready. The second one enables the 8x gain, gives you more resolution. The third one defines the time that the sensor calculates the data for, and then we enable the ADC. You can see there's some other registers over here. You may be able to fine-tune some stuff on your own. He also has the register write function, the register read function, which is used as we just saw up here above. And then he actually has the ambient light read function, which gives you the value in lux on the light. And we can see there's a bunch of arrays and values initialized, and then there's this very important equation down here. If we look up in the data set on how the lux is actually calculated, you'll see that there's a calculation here that takes in the time and the gain and the data values and then calculates the final lux value. Okay, I have my TinyDuino down here. Also, I have the USB ICP board. And then finally, I have the Ambient light TinyShield. I'm going to go ahead and connect these up. USB into the TinyDuino itself. Then the Lux Shield into the USB. I'm going to go ahead and plug in my USB cable. And I'm going to go ahead and upload the sketch. This may take a few seconds. As you can see, my light is flashing there as it programs. It's compiling the sketch and uploading the sketch. Alright, the sketch is uploaded. I'm going to go ahead and open the serial monitor. And since we're using the serial monitor that's linked to the LED here, you'll actually see when it transmits data. I'm going to make sure you're at 9600 baud if you're not getting any results. As you can see, the lux values are being spit out there in the serial monitor window, and it is very accurate. If I put my finger over it, you can see the lux value decreases quite a bit. If I take my finger off, you can see the lux value increases to the ambient light that's in my office here. Now, I've tried to get this thing to go to 0. If I stick it in the palm of my hand and tighten it up really tight, I can get off a close. Sometimes I get a couple negative values, but this thing is so sensitive that it even sees the tiniest bit of light, which can be a good thing or a bad thing. For some projects, you may actually have to round the amount of lux or dumb down the actual intensity of the sensor to get the value that you want, or maybe turn off the gain altogether. I'm not sure. I haven't played with that yet, but that's something that you could do. Alright, again, this is Joseph Stackhouse with Stack Tech. This time I did a lot more on the specifications of the actual diode here on the shield so that you would actually understand how the shield works and how it works so well. Some of you may like the in-depth analysis, some of you may not. You can leave me some comments and let me know either way, and please hit like and subscribe. I will be making more videos yet on the entire line of TinyDuino products. At least that's my goal. I would love to meet it. Your subscribes and likes really drive me to make more videos, so if you'd like to see more, hit those buttons. And until next time, this is Joe Stackhouse with Stack Tech.